Yo, what's up, everybody? Welcome back. Today we are working on making a window manager. We are on day 3 of this thing. We are working on Linux with Wayland, and we're trying to use very, very few dependencies. So no lib Wayland, because I don't like its API. No WL roots, because we're gonna do it all ourselves, right? We are going to accept GPU driver dependencies as well as libdrm dependencies, which are just like thin wrappers around Linux's APIs to talk to the Linux, like the GPUs. There are like these like ioctls that you can run, but libdrm just gives you like nice little like function wrappers around them. And it's like if you look at like the kernel development wiki or like the kernel development docs, like they're like use libdrm. So like we're not gonna get too fancy with it, but where we are right now is we have a Wayland client that we've written. Zig out bin Swayland client, right? Just a little thing. He opens a window, renders the little blender monkey, and spins it around a little bit, right? This is using everything. Whoa, that's not good. There's a bug in there that we need to fix. But you know, he's doing his thing. I think we're forgetting to close some file descriptor somewhere. We also have a Wayland server, that this guy can talk to. If we say, please, sir, run over there, he can like talk to him and he passes his GPU buffers over for render, but our implementation does not actually, he does not actually do anything with those buffers yet. And eventually, our implementation gets upset because we stop being able to successfully like swap with this guy, I guess. Like we run out of GPU buffers to work with because this guy's never given them back, right? So the way all of this kind of works is we have our window manager, we have our client. This guy exposes a Unix socket at like some spot / Wayland 1 or whatever like Wayland socket he finds. The client like connects that thing. He starts like sending Wayland messages back and forth. Eventually the client like draws some stuff through, we can kind of like skim over the details, but eventually he draws with like OpenGL and he like extracts the buffer that he drew to from OpenGL into this like file descriptor. It's called DMA buff or DRI prime file descriptors. These are like a Linux feature to basically expose a GPU buffer as a file descriptor, which allows us to send the file descriptor over the Unix socket, which is supported, into like this window manager. And so in this window manager, we have this like file descriptor that represents a buffer on the GPU. And what we haven't done yet is done anything sane with this thing, right? We just have it. And so the next steps are trying to figure out how to draw to the screen from this. So that's the plan. We have, you know, our previous work here involves a quick and dirty example of getting something up and running on the GPU. Or sorry, so this is a like Linux VM with our app in it. And once he finishes booting, give him a sec, boy's thinking. We should be able to go like this and then something shows up, right? So we have an example of something happening. But we need to like convert this into something that is used in our app as well as like imports the buffers that he needs to import. So I think the plan of action is kind of integrate that like render stuff to the screen stuff into our app. Probably also we're gonna have to figure out like cross compilation is actually probably step 1, right? Get our Wayland compositor running in the VM, then like display like hook up this like GPU, the rendering stuff. Then we have the file descriptors from our client, but we're gonna have to like import them somehow, and then, you know, render it. That's kind of the goal. If somehow that takes under 15 minutes, we'll do like input, but it won't. So nothing to worry about there. All right. Let's do some cross compilations. It's gonna be like always GPU buffer exchange, no software rendering. It's always hardware GPU rendering. So I guess I kind of skimmed over a detail here. So I think the client always has to expose a DRI prime handle but these can be backed by like M-mapped CPU buffers. So you can do the rendering on CPU, but it's just like the conversion of those things to a GPU buffer will be a little bit different. And then yeah, you can also do like CPU OpenGL rendering and stuff as well. This is another option. But it's a reasonable question. Okay, so when I say cross compilation, what I really mean is compilation for a system that is not us, because this Linux virtual machine that we have is running Alpine Linux in a virtual machine, which means like the libs that we have available are like in the Alpine sysroot, and it doesn't really follow like we can't like link against host libraries. We need to link against libraries that are in the VM. So kind of like by default, what's supposed to happen is if you like specify target on the command line in build, and you even if you do like x86-64 Linux, I think this is a Musel based thing. How do we not like resolve target? Oh, is it -d target maybe? x86-64 Linux Musel. There we go. So what's supposed to happen is this shouldn't fucking build. But I think what's happening is we are manually adding include paths to our thing. So we just need to not do that. So we should do like if self target is not equal to the host target, then we shouldn't do this stuff, probably. I'm surprised this works, because even then, like, linking should fail. Hold on, let's take a look at this. Let's see what this outputs if we do that. So if I understand correctly, this guy should try to use LD Linux. Yeah, this is wrong. Because he's supposed to, like, try to use the Musel loader, right? When we do target is x86-64 Linux Musel, if I do like d asdf equals this, he does say that doesn't exist. So are we accidentally using like, we're not like, oh, we are using this in a couple places on like code generation side, which is correct. That is what we should be doing. But I would think that it shouldn't link. I would think it shouldn't link. That's my experience before. Can we look up like build zig cross compilation? Let's just do like a stupid thing here. And can we just try compiling for like AR64 or something? Right, so like this should result in like some like dumb shit. Oh, AR64 is a bad example. Yeah, so here he's like, I can't fucking do glibc linking, which is like super reasonable, right? He's like, I can't find this stuff, right? Where do these headers come from? Clear cache, yeah, maybe we should try that. I could also be wrong about the behavior of when we, yeah, like this, I don't think this should work. I guess we could also try, so if we were to like just copy paste these things into our VM, like would they work? I guess that's the question we should be asking ourselves. So if we like take swim and copy it over there, scp swim root at, I think it's p5555 root at local swim root at localhost. Like this shouldn't run. Oh, it does. Okay. So I'm surprised there, actually. Oopsies, LDD swim. Oh, it's not a dynamic executable. Wait, that's kind of hype. That's kind of hype. I didn't realize. Okay. And I guess it's because we actually have like no fucking dependencies. What if we copy the client over? Surely not, right? Surely not. Wait, he does run? Holy shit, that's crazy. So I guess it means that all of the stuff that he depends on, he did like resolve correctly. Wait, that's kind of surprising. That's kind of sick. Okay. Wow. Okay. I got a little excited. I was like, there's no way that works, but I guess it does. That's actually like incredibly surprising. No, there's still something wrong here. Right? Because the linking should fail because we haven't told it where the fucking libraries are. So there's like still something wrong here. In that Zig includes internal Moosel. Yeah, but what about like their fucking libgl? Like it must be linking against my system libgl and then just happening to transfer the like dynamic symbols over or something. Or maybe, yeah, there's like something wrong there, but this is good enough for now. we'll put like a note in our brains. It's like something doesn't seem right here, but that's a problem for future me. Okay, so let's update our swim window manager to try to like he needs like in some loop somewhere to be rendering stuff to the screen, right? Which means at the very least we have to start by getting up and running. So can we look at like our tests thing? This is our example of how we get rendering up on the screen. So this is like the simplest raw dog Linux frame buffer, or like frame buffer? Not frame buffer, I don't think. Draw stuff on the monitor. If we look up Linux KMS, which does not stand for what you're thinking, it's kernel mode setting. Basically, like the pipeline. Is it a given that libgl requires glibc, or am I missing something else? Yeah, I think that the loader is still Moosel, but then glibc is also installed or something. Like, I think that if we LDD this thing, libc, oh no, it's got libc.so is still Moosel in this list. Yeah, it does seem a little sketchy, but we'll tackle that. We'll worry about that when it becomes a problem. I guess we should try. You are kind of right. I guess you are bringing up like a good point that we should make sure that if we SSH here and we try to run our like, you know, if we run swim, we do like xdg runtime dir equals temp, and then we go in here and we run like xdg runtime dir is temp with wayland display is wayland 0. Like, no, I mean that's working to some extent. Yeah, I mean that's doing something, right? So we see him getting all the way to, he does try to do a couple like driver loads. Eventually he like doesn't really get the right one, but he does get to the point where he is sending a file descriptor over, right? So if we do like ps-aux grep swim over here, and then we look at like cat like lsdsl proc 2140 fd, we do have like some DMA buff file descriptors in there, so it looks like it's doing something. Whether or not that thing is sane is like unclear, but it's doing something. So I guess we can kind of like consider it okay for now, right? At the very least, it like loaded libgl, ran OpenGL calls, and like created a buffer. Okay, so back to this stuff. So, you know, if we imagine our computer monitor, right, plugged into like the desktop tower with like the GPU sitting here, right, with the CPU, you know, over here somewhere on the motherboard, like a million pins, right? You know, the GPU has hardware to encode the signal over this connector, as well as like detect if the connector is plugged in, and also to like control the resolution of this guy, right? He will like send commands to the monitor to change the resolution or whatever. Or maybe he's like encoding for full resolution of the monitor, but like down, like he's doing like the upscaling on the GPU or something. I don't really know how it works. But basically, it's like, here's, you know, there's like some abstraction for a connector, an abstraction for encoder that does like the wiggly wires. There's an abstraction for like the controller is like what you can think of this thing as well as like planes and buffers that you like feed into that thing, right? So in this like example that we made a while ago, you know, he finds the first connected connector by issuing a call to libdrm to like look over his available resources and just like rip over those until he finds like a connector that's connected, right? He then like takes that connector and figures out like what resolution do we want to render that thing at. We like create a CPU backed buffer at that resolution. We add that buffer to like as like we create like a frame buffer out of that thing, and then we, I think, attach that frame buffer to the controller. Yes. So like we go, yo, I need to like find an encoder for my connector. I need to find the controller for that encoder. Then like we do some drawing, and then we just like say, yo, controller, show this buffer. So what we should be able to do is, from Kwin's perspective, we should follow like a lot of these same steps. It's just what we draw, this frame buffer needs to come from what came over the wire, is my understanding. And so I think that that's like doable. We just have to figure out what's supposed to be done there. So I think, and we have to do that at some frame rate, but maybe for now, let's only worry about displaying the first buffer that comes in. I think that's reasonable. So let's kind of like copy paste this whole file somewhere. And can we go into like swim, and let's make like a source swim, and let's call this like backend for now. Paste. And let's, instead of running main here, can we do something that's like initialize DRM? And this is going to return some sort of like DRM handle or something, right? We don't really know what yet. But so this thing's clearly going to have, at the very least, he needs to be able to talk to this control CRTC thing. He needs to have which means that he needs to be able to call this function. So everything that's in this function has to be here, except for the frame buffer, which will come from somewhere else, right? So we need CRTC ID, which is what? Who knows? We'll figure it out. He also needs a file handle. Maybe we'll just call this file. We'll call this like DRI file is a stud fs file probably. We also need this connector ID and the preferred mode. And this guy is gonna be like, I'm gonna return a DRM, right? I'm literally just gonna do whatever the fuck was in main before. Except I'm not gonna map this frame buffer anymore. Fuck that shit. But I am going to find my controller. I'm not going to do any of this stuff, probably. And then I'm just gonna return this, right? So we've got like CRTC ID is CRTC ID. We got DRA file is F, right? We got connector ID is connector ID. We got preferred mode is preferred mode, right? And then I'm sure the compiler will scream at us that we're doing something stupid. But now we can just kind of call this from our main. Right? So we can just kind of off rip, be like, backend main. Nope. Initialize DRM. And let's just see how this falls over. You know? Okay, so this guy's, now we're getting into the good shit, right? He's mad that this stuff is missing. So we should be able to do, zig build detarget. He's still mad. And can we do like, do we have like sysroot in here? Yeah, we do. We have sysroot is going to be Linux env. We have this env. We just basically like copied the root of s over from over SSH to this folder. How does like search prefix work? Because like, okay, so I know that this file is in there. I'm like 75% sure. Find // Linux vmm rootfs I name this. Right? It exists. So we have to figure out how search prefix works in here so that like it finds it. You know? So can we go to like stud build search prefix? So if we have like I guess we need to check like the build runner first. Compiler runtime, build runner, compiler, build runner. Here we go. So this guy's gonna have search prefix is going to set this builder add search prefix. Okay, cool. So we have builder search prefixes, and then we got to figure out how this is used when linking, right? So he does use it for bin, but what about like if we go to like build step compile, right? Like compile, right? Does this guy use search prefixes at all? Yes. Okay, so when he's looking for -i and -l, he looks at search prefixes for each search prefix, which one of them is that spot. He looks for lib in the prefixer and include. So we want search prefix to be pointing to user, not the root fs, I think. That's a lot better. That's a lot better. Right? We found xf86, but now he can't find this stuff. So can we look at this? Is some of them here? No. So we have libgl, we have libegl. But he's mad because user libgl.so does not exist. In the I mean it doesn't, right? So we need to like why does Alpine symlink.so files like Alpine Linux missing .so without trailing version. Kind of this, right? No, not really. Oh, we're also not linking against libc. We should fix that. Let's fix that first. That's the easier fix. So this guy link libc, that solves one problem. We are missing -drm. Can we like manually add include paths? Is that like legal? I guess. Because drm.h is like hidden behind libdrm here. So we need to add that as well. But it doesn't look like it's like easy to pass that in, which is a little annoying. Can we do like add include path, add system include path? Can you do multiple search prefixes? Is that allowed? If arg is this, oh, it does actually look like you can just like rip that shit twice, huh? There's nothing stopping that. And then if we go to that compile step again, good thought. So search prefix, he's going to look at the prefix dir, he's going to try to look into lib, he's going to try to look into include. And if there's no include path in there, he's going to get mad, right? Right, because include folder doesn't exist. I mean, we can just hack it for now by linking libdrm up one folder. Let's just do that. That's easier. Right? Yeah. Let's just do that. Let's fucking hack it. User include. Oh no, he is definitely gonna need this. Right, because this is gonna include more shit. Maybe not. What we could do, we could just go for B, like self B search prefixes. Right? We can do exe add system include path of prefix like this / libdrm, right? This is good enough for now. Yeah, this'll work. That will do. Are you supposed to include drm.h or include libdrm.drm.h? Yeah, I agree. I would think that you're supposed to include libdrm.drm.h, except that it's a transitive include, so we don't have the fucking choice. We can't do what we want. We can't do the right thing here. You know what I mean? It's like not our file that's including it. I think. Maybe it is. Maybe I'm a fucking idiot. I thought, oh yeah, we can double check that. Backend. Yeah, right, we're only including these guys, and these guys include DRM directly, so it's like their fault, not mine. You know? You know? I did just put the allocator in the wrong spot here. So true. Okay. Forgot to try here. Okay. Still not found? Are you fucking kidding me? Right. I do have to write include there. All right. That's looking a lot better. So, still some of these linker problems, which we can also maybe hack. I guess it just says warning, which maybe is fine. The things that are actually erroring right now are our usage of DRM. So let's just kind of do this. Try here. And then he's also mad that the preferred mode here is being stored in the incorrect way. So does this stuff, is this resolving? It is. Hell yeah. Oh, but like libdrm is not probably. Yeah, that makes sense. So what is this type? He's like saying that it's a like DRM mode info. So this is like DRM mode info. Well, kill me, huh? What the fuck? DRM mode info, my bad. And then maybe it's a pointer. Yeah. Okay. This guy also does need to link against libdrm. That's so true right now. Link exe link system library libdrm. Okay. So now this guy's got error warning. Yeah, okay, so he's fucking failing to find this shit. So I don't know, like, I don't know if this is like a Zig bug. Where, like, is he supposed to find these guys despite the fact that they don't have, like, what's going on here? You know what I mean? You know? Like, we're just missing, like, he's like, I can't find libegl.so. It's like, yeah, it doesn't fucking exist. Right? So, like, yeah, of course. So are we like, who creates those? And is it like, is Zig supposed to find, like, why do a bunch of other guys have these? Is another question. Maybe we like don't have, maybe we installed Mesa, like, can we just like search EGL? Like, what the fuck is going on here? Like, do we have apk add Mesa dev? Maybe like the .so links are only there for when you are linking against those things, and then like the linker usually like resolves them a little bit better. The idiot told me that .so comes with the dev variation. Yeah, that's not insane, right? Because you could argue that like when linking, the compiler is supposed to like walk through the symlinks to find the actual concrete file that you have, and so like the .so without like trailing versions is really just for compilers. You could like make that argument. So can we look at user lib here? I don't want, no, stop. libgl star. Yeah, there we go. Okay, so we just need to like re-rsync this shit now. Rsync? Oh, wait, do we have sync root of s? Hell yeah. Bum, 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 bum. Well, there's a lot of shit to sync. Like all of Python 3.12. Yeah, I guess fuck me. All right. Cool. So I guess the answer was no, not a Zig bug. Okay, so this is a lot better. I guess we also need libdrmdev, right? Add libdrmdev. All right, we need to sync that shit. Linux vmv sync root. All right. Wait, what the fuck? Shouldn't that have installed something? ls user lib user include. Yeah, wait, it was already there. Wait, so what's he pissed about? Huh. Something's wrong. Right? Like, he's resolving against some, like, real system shit that he shouldn't be. I thought that, like, passing target here was supposed to disable that. I thought. Zig build. Okay, so like where would he be getting that from is like the question we have to answer, right? I think that what I've seen is that at least what we did for our hack for translate C is that we like walk the output of this command. So we run gcc-e-wp-v xc dev null. And he prints out a bunch of things, right? Like the fact that libdrm might be there, right? Maybe. So he might be doing that. It would be interesting to see, I guess, in like the builder. I'm pretty sure I stole this from Zig's own source code. So can we look for -WP? Right? So we have like find native include dir POSIX, right? Is like a thing that they might run when they call like find native in here. This is in libc installation in std zig. So can we look for like find native? Like who calls this here? Looks like this guy in libc. What does this do? Zig libc. Detect native libc installation and print the resulting paths as standard out. Oh, interesting. I didn't know this existed. We could have been doing this. We could have been doing this. But I guess this is specifically libc. Like, okay, if we type zig libc, that's kind of cool. I didn't know that existed. But this doesn't have like extra paths in here, right? Unless we type this. Yeah, like target x86 64 Linux GNU or Musul. And it's like non-native target, right? So it knows, right? That's what's interesting here, is like he fucking knows. So there's something else going on here. You know, where can we look at maybe link system library? You know, like m link objects append. I guess like he might be using package config. He might like, what is like our options search strategy? Paths first. Use package config. This seems a little sketchy. Can we just say like use package config false for a second here? I just want to know. This guy wants an enum. Look at these guys. Yes, no. No. You know, let's just I guess the problem is, oh, whoa. Can we do this instead? Use package config is no. Okay, so that does kind of fix it. So I think that maybe our package config path. Yeah, we need to fix this. That's what it is. We need package config path. Should come from Linux vmm rootfs user lib package config or something. Let's fucking go, baby. Let's go. All right. So this thing is fucking compiled, baby. And so we should be able to then like ship this over the wire. Let's let's put this somewhere. Oh, geez. Move cross hs cross sh. Okay. Boom. Okay, and then scp can we also do like, how do you like install SSH keys again? SSH copy ID to root at localhost. And then now when I do this, and I can do like end scp zig out. Can we just do this? scp -r zig out to root at localhost. What? I fucking just copied my key ID. I fucking shouldn't have to do this shit. Oh, I forgot the -p. That's why. I'm trying to copy to like my actual root. That's funny. There we go. Okay. And SSH 5555 root at localhost zig out bin swim. Okay. Nice. And then we can do like okay, let's only copy actually bin swim like this. And then we can do like a little bash-c xeg runtime dir is temp. Is that all they needs? Bash not found. Fine. sh. Okay, he doesn't like that, I guess. Fine. Fine, I'll fucking run it myself. Okay. xeg runtime dir equals temp. Okay, so he's sitting there, he's serving, and he has opened DRM, right? So theoretically, as long as we are like capable of importing the buffer that we got, we should be able to display it. We should. The question is just like how. I guess what we should do is like we should set up our commands to be a copy, and then we should just run it over here probably. Okay. So somewhere we're going to like get that file descriptor. And can we just say when they commit the surface, we are going to look at our surfaces, right? Which we have right here, right? The surface needs to link back to his current buffer, right? So somewhere I think that like one of the things that they're gonna do is they're gonna call like attach or something. I think it's like, can we look at log unhandled requests actually? Right, there's gonna be like attach, right? So they're saying object 7, we attach this buffer to this thing. And then they damage it. So we need to, when they call attach, we need to kind of like hook that shit into the surface, right? So we're gonna say like, this is our surface, we want a pointer to this thing, and our surface.buffer is going to come from params buffer. And this params buffer is actually going to be like a buffer ID. So we're gonna say buffer is WL buffers, get pointer, maybe get handle. That seems reasonable, right? And then we say like surface buffer is this, right? Then we just need to like define that when we work with these surfaces, we have like a buffer that is like maybe, you know, one of these. And then when they commit, we can look it back up, right? So when they say, I commit this surface, we can try to display it by going like state, or we have like state WL buffers get from surface buffer like this, right? We say like, or else, I guess like if there's a buffer, then we can look it up. So this is like state, WL buffers, item, storage, items, buff handle. We should be careful. We need to strong type these handles, by the way, because I am 100% going to fuck up the difference between like storage handle and wayland handle. Strong type buffer handle, like storage versus wayland handles, because I'm going to fuck that up. 100%. 100%. Any specific reason why you chose Alpine Musil for the VM? Because it's small. I was going to do like my own RAM disk, and then it was like too much work. So then I just like looked up like small VM. Okay. So we have this buffer, and we should be able to just be like backend. So this buffer should have buff params file descriptor. So we need to start by trying to import this thing. So can we just like throw this into like backend load buffer, like display DMA buff, and this guy I guess is going to take in like buff params FD. He's going to take in a bunch of shit, right? Buff params, you know, all of this stuff probably. So let's just kind of figure out how that works. Pub function, display DMA buff. Presumably this thing is failable, and we know that like the end goal here is for us to do this. Display shit on the CRTC, which means that here we certainly want this to be like probably like a child of this like DRM thing. Right? And then he's gonna be like self DRI file like this. This is like self CRTC ID. Boom. We don't have a frame buffer ID yet. We're gonna have to make one. Which means that probably like there's like create frame buffer or something is probably like a separate call here, but we'll deal with that later. I don't know what this like connector ID output is, but I guess fuck it. Preferred mode. Self dot. Okay. Let's just kind of see where this goes. So we need to like import this thing, right? So there's like DRI prime frame buffer import is like a thing that exists somewhere. Prime import, right? Prime buffer sharing. So import buffers, you know, you can do this somehow, but this doesn't really seem like, maybe this is in libdrm somewhere. Feels like the type of thing that would be in libdrm somewhere. You know, user include libdrm. Maybe in one of these as well. Can we just like grep for prime in here? Yeah, so there is this prime handle to FD, right? Like there's stuff like this. I want like FD to handle. Okay. Okay. So we can call an ioctl that will give us a DRI prime handle, and then what do we do with this thing? DRM, like, can we DRM prime handle in here? So like, can we use that anywhere? Doesn't particularly look like it. What about like up here? Okay. Unclear, but so this gives us, I think, a like gem handle, where gem is like Linux kernel internals buffer management, I think. Which might be the same. It might be the same as what we have in our like test thing here, right? Somewhere we create this like dumb buffer here. We like map a dumb buffer, right? And then we feed that thing into a frame buffer somehow. Add frame buffer here. So dumb is after. So presumably we still do this, right? We probably still make a frame buffer. And then it's like, how do we map in our handle, right? There must be something like map call. Maybe not. I guess map might be for mapping it to user space, actually. This doesn't attach it to the frame buffer. How do we attach it to the frame buffer? Literally the only place this frame buffer is used is here. So, oh, here. It's when we add frame buffer, he gets a dumb buffer ID here. Create dumb buffer. Oh, I see. We create the dumb buffer. We add the frame buffer with the dumb buffer ID. So it depends on what DRM mode add frame buffer wants, right? If he wants a gem handle, then maybe, or like a DRM handle or whatever, maybe we're fine. You know? Grep this. So this comes from here. Okay. Creates a new frame buffer with a buffer object as Gendo. This is a BO handle. Okay. DRM prime handle. Handle? That's not insane. Not insane. Is there like an example? DRI prime FD import DRM. Like, let's just lib DRM. Oh. Blah, blah, blah. Can we look up, like, prime? Okay. This is about that. The render nodes. I don't really care about that. More render node stuff. Prime. Oh, here we go. Yeah. FD2 handle, maybe. We'll return the new handle. Okay. Can we look up maybe add FB? I would love to see like docs for that ioctl, right? So maybe this is in like the kernel somewhere. What's prime? Prime is like, if I understand correctly, I mean, it's very hazy in my mind, but I think prime is like the way that we export file descriptors of buffers to share them between processes. So my understanding, like, I first heard about this, like, in the context of multi-GPU stuff, like, way long ago. But yeah, I think it's just sharing buffers, GPU buffers through file descriptors, is my understanding. Could be wrong. I would love to just see this, like, fucking add FB. Like, I would just love to see, like, the kernel docs for this function. This looks like he's got, like, a 2 here, which makes it sound like there's, like, a man page. Man, DRM, octal mode, add FB. Like, nope. Would've been cool. There we go. Okay, frame buffers are abstract memory objects that provide a source of pixels to scan out for a cathode ray tube controller. Applications explicitly request the creation of frame buffers through this, and receive an opaque handle that can be passed to the CRTC control, plane configuration, and page flow functions. Frame buffers rely on the underlying memory manager for allocating backing storage. When creating a frame buffer, applications pass a memory handle or list of memory handles through this thing. For drivers using gem, fuck, I accidentally fucking dragged and just fucking like nuked me. For drivers using gem as their use space buffer management interface, this would be a gem handle. Okay, so I think that we are in this case. I think. I don't really know what it means, but I think so. So I think that we take the file descriptor, we convert it to a gem handle, feed the gem handle into this CRTC controller shit, and it should show on the screen. It's not like 100% not gonna work. It's like, it's not a crazy hypothesis, and we should probably like assume that the kernel will just scream at us if we're doing something like really fucking dumb. So I'm not really against it. So I think here we create a frame buffer out of this thing, right? So we're like, yo, let's fucking take this thing. We need this like preferred mode shit, which we have. Although I guess like maybe this should be using the parameters of the buffer, not not the parameters of our screen, right? So where did we set this up? Where we were calling this? It was in main. So here we also want buffer width, height, format, like just like fucking like send it, you know? Flags, just like a fucking go crazy. Just fucking give them everything. So buffFD is cint probably. Modifier is U64. Offset is U32, I think. U32, U32, U32. Width and height are I32s for some reason, and then everything else is U32. Yeah. Okay. Plane index, U32. Stride, U32. Width, I32. Height, format, U32, and flags. Okay. So we have all this fun shit. So using the width and height here for the frame buffer size seems reasonable. What are these other things? DRM mode, add FB. FB. Fine. Surely this is stride, I assume. I don't know what this 24 and 32 are. I assume these are like bit depth, maybe? DRM mode, add FB. I think that this goes to here. Maybe DRM header? Oh no, this is in XF86 mode, right? Add FB. So this is bit depth and bits per pixel. So these have to be extracted from the format code probably. But we know that it's 3232. I think it's RGBA, I think. I don't know, we'll see. If it's fucked, it's fucked. This thing needs to come from the handle, and this is going to give us a new frame buffer. So here we need to get like our buff handle from, what was it? To handle. So here, this is like an ioctal number. So he wants a DRI prime handle as his argument. So this is FD to handle, and then do handle to FD and FD to handle. They use the same structure, right? So they're just gonna go in opposite directions. So we should be able to call like, it's like some shit like libdrm, I think probably exposes like a DRM ioctal function, if I remember correctly. DRM ioctal. Sounds familiar. Ioctal. Which is like, just like call some shit. Maybe we just call ioctal directly. I seem to remember there being something else. Yeah, there's this. DRM ioctal. So here we call like DRM ioctal on this guy. And we're looking for, you know, whatever that number was, right? Whoa. To handle. It was this, FD to handle. So we want to call this guy, which I think that we might not get access to here because it's like a define and Zig doesn't like import those nicely. So we might have to get a little tricky here. And then we have DRI prime, what was it? Handle is C DRI prime handle. I finally get it now. Octal's auto control. Yeah, exactly. So flags is empty because it says only relevant for handle to FD. We're going FD to handle. We have FD is equal to buff FD and handle equals 0. And we're hoping that when this is done, that we have a handle. So this guy, I think, is going to return like, let's see, man octal. Return. Blah, blah, blah. Otherwise, it's just return -1 and set error. So if, I think this is, if ret is less than 0, return error, create handle, right? We'll start here. Then if this thing exists, we should be able to slap that handle in here, right? And then here we have a frame buffer. And then are we just chilling? What about all of this stuff? Like, why don't I need this? It seems crazy that we're missing all of these things. But maybe these are for, like, OpenGL info? Right? Like, surely we've fucked something up here. Surely. DR mode add FB2 looks like it takes those things. Oh, good fucking call. Good call. Yeah. Good shit, dude. Thank you. Okay. Width, height, pixel format. Buffer handles. So this is going to be like this. Handle. We got pitches. Stride, which we called it. Offsets. Offset. Buff ID. What is that? Oh, this is, sure, the return value, and then flags. Nice, dude. And then maybe this displays. It would be cool if this compiled and ran. That would be so fucking cool right now. Plain index. Ignore it. We don't need it. Modifiers as well? Are we fucking... Did I miss something? Oh, add FV2 with modifiers. With modifiers, width, height, pixel format, handles, pitches, offsets, handles, pitch, offset. Modifiers. Cool. We're still missing plain index, but fuck it. I think that might actually come in on... I think the frame buffer will have multiple planes, actually. And then maybe somewhere... Maybe here, one of these zeros or 1 is the plane index. Let's see. Set CRTC. Set CRTC. No. My function 2.0 final docx. Yeah. Is like plain in here at all? There's this. Right, so maybe we attach it to the CRTC and then we can choose which plane we want to show. And this is how we do like composing, right? So this would let us like position this thing like it's got some size and our screen has some size and it like lets us pick that or something. But we'll kind of tackle that later, I think. Okay. So what's going on here? Right. So this is not backend. This is like self DMA context or something. DRI context. DMA is the wrong word here. DRM is what we call it here. DRM context, right? State DRM context, maybe. Okay, so here we have DRM context here, which is going to be from like backend DRM like this. Then when we create this thing, where the fuck we do that, it's like DRM context goes in here. Okay. And then whoever calls this needs to pass it in. I guess. Okay. Okay, wait. Okay, okay. Okay. DRI prime handle does not exist. But I saw it. I saw it in live DRM. DRI struct. What was it called? It was like FD to handle, right? DRM prime handle. My bad. My bad. Sorry, dude. Oopsies. Oh, and then this is also just like cross. We're using the wrong compilation. Area union is ignored. Okay, width here is the wrong type. So true, dude. I don't know why the fuck they're I32s to begin with. U32 does not support array initialization syntax. Add FB with modifiers. Pixel format. Okay. File descriptor with type pixel format. BO handles. Oh, maybe he wants this. Oh, wait. It needs to be for long, though, right? It does need to be for long. So here we need to be like handles is for U32s, right? We just have to do it this way. And I assume you splat in something like 0 or -1 or something to like, I don't know, right? Something like this. Modifiers. We'll just throw 2 S's on this. How about that? For the plural of modifiers is modifiers. And then we do like handle 0 is equal to DRI prime handle. We got strides 0 is stride. Offset 0, offset, modifiers 0, modifier. There we go. And then this is like handles. Oh fuck! I should have been paying more attention. Handles, strides, offset, modifiers. Strides, offsets, modifiers. All right. Yep, U64 here. So true right now. Then this preferred mode thing here is like this. No. Is he mad because it's a const pointer? Yeah, it is. He is. Just delete the const here. Easy fix. Okay. Get handle expected U32 found U size main zig 418. Yeah, I think that's cool. U size here. Okay. Let's see how fucking wrong that is. So if we go display equals wayland 2, and we run this wayland client, no wayland display, xdg runtime dir equals temp. Am I stupid? rm-r temp wayland star and this. Okay. Am I oh, it's wayland display, not display here. And I guess doing this in the fucking window here is also stupid because it will, like, we won't be able to see it when we won't be able to, like, what am I trying to say? Like, the screen will overwrite itself. Having my OCD can maybe help. Its modifier is singular in the original struct that you pass in the function. 2 S's is more fucked and therefore better, though. Yeah, I think it's funnier. I was going to change it to a modifier, but I'm like, this is better. Wayland display equals wayland 0. Wayland client. All right. Fingers crossed. Connection failed. Add FB. Add FB. Okay. So that's good. Right? This fails. So then the question becomes why? We need to look at Erno, right? How do I get this? Like, is Erno not something... What a good fucking dog. Erno... Oh, here we go. We have extern thread local var Erno. Is that what we're supposed to look at? No, this is in private. Are we supposed to use the underscore version here? I guess so. Unless, like, there's somewhere else who's supposed to call this. Let's look at the Zig docs. Nope. Learn. Here. Erno? Stood POSIX Erno takes in this thing though, right? Oh. Ah, I see. We throw an rc equals -1 on there and he'll give me Erno back if we're using libc, which comes from stdc Erno with underscore function point. Okay. So that's what we're supposed to be doing. Right, so then it's like std debug print, error code is this. Right? Cross, run that shit, Control C here. He's mad because what? I fucked this up? What is return? Cint pointer? Holy, that's crazy. Swim. Wayland. Okay. Error 22. So what is that? Linux error codes. 22 E invalid. Great. That's super cool. That's so sick. That's so sick. All right. We're getting into it. I have a Linux kernel somewhere in here. DRM mode at FB. FB at modifiers. Like, where is this used? DRM.h sounds right. DRM ioctl mode add FB2 modifiers. Like, where the fuck is this used? Nope. This. FB2. Can we look for this now? Oh my god. I want to look for this. There we go. Okay, so when is he gonna return Ian Val from this guy, right? So we could look at dmessage here for some clues, right? We need to turn on kill my kernel mode setting DRM debug logs. Where is this? DRM debug KMS. This is like a macro. That calls this guy. Who is like what? This guy is calls underscore function. Who lives in another file. DRM print.c? Maybe? Yep. Who is DRM debug enabled? Where does this come from? Is this like a procfs thing that I can like check? DRM enabled raw. Unlikely DRM debug and bit category. DRM debug equal DRM debug like hello? Hello? Oh, here, export symbol here. Yep. So this is in DRM print.c. We've got a bunch of bits to set on this bad boy. Presumably this thing is like, is this like exported like through procfs module param? Yeah, so this is probably in proc, right? Probably. CD proc module, sys modules maybe? DRM mod probe DRM print. Is this like yeah, so is this like it's like it looks like it's like its own module? Oh, this is only if not config DRM used yet. Wait, what if this is enabled? It probably is, right? If this is defined, then it's DRM debug enabled instrumented. Oh. Then, okay, well, I guess we should check, right? Cat proc config. No? ls proc config. How do I ls boot maybe? Do I see like config? Yeah, nice. Dynamic print, right? Was it dynamic debug? Yeah, let's fucking go, baby. Oh, that's config dynamic debug. What about DRM? Oh no, who knows? DRM use dynamic debug. Is if this config DRM use dynamic debug is on, sounds like maybe it's not. Right? Does kind of sound like that. If it was on, where would I see that? DRM print. So here it's like, oh wait. Is this not just the same shit? It just go to the same place, right? DRM debug enabled raw. So this comes from bit category, and this comes from, right, DRM debug. So how does this get set then? Here. So if we have dynamic debug, This goes into declare dyn debug class map and module param callback on this thing. Yeah, so it would be like this module is being included by who? DRM print.c, like which module is part of this? DRM makefile. This is so hard, man. Okay, so this gets print O if unconditionally, if DRM is enabled, we get DRM print. So at the very worst case, we can add a module parameter to this thing, but he's part of like the DRM system. So we should be able to go to like in here, parameters, debug. So we should be able to write dynamic debug flags into this thing, right? If we find the right bit to set, which was KMS, right? So we want to set, so how do we get, I think we just write 4 into this thing, right? Echo 4 debug. And then can we like run all of this shit again? Maybe. We can hope. Let's fucking go! Let's go! Holy! So it's just bad frame buffer modifier for plane 0. So that's a lot deeper than I would have thought we got, right? Bad FB modifier for plane 0, right? Which means that like that means that we've got like the right handle. Right? We've got through all of this stuff. The pitch is correct, maybe. Like we have a buffer object handle for this plane, maybe? Like, it seems likely. It's just the modifiers thing is backwards. It's possible, or like wrong. I guess we should find out why. Modifier, so if modifier I and not R flags DRM mode, could be either of these, right? Is it bad modifier or bad modifier data? Which one is it? Bad modifier. So it's could be either of these. So if R modifier I is not equal to R modifier 0. Oh, all the modifiers have to be the same. How do we like bail out? Like, so what happens if we didn't really like look into like what if we fucking num planes? Where does num planes come from? Num planes. This is what we were fucking missing, right? Num planes. How is that not a piece of this? I mean, we could do this to try to like get past it. Oh, fuck me. Also this, we use the wrong fucking type here. All right, let's try that. Let's just see what happens. We don't have to be too crazy. Whoa. There we go. Okay. Okay, so we did still fail. And bad FB modifier, this for plane 0. Oh, okay, so that was actually a clue, right? Where was the kernel stuff? Here. So it's bad modifier for plane 0. So we know that this works, right? So it means that it has to be this, right? that our flags does not have DRM mode FB modifiers, which means that we probably have to supposed to put this in the flags here, would be my guess. Yeah, I don't know what. Oh, yeah, flags here. This is the wrong flags, by the way. This is like this is the flags that came in from Wayland. So this is like fucking stupid. We shouldn't be passing this. Like, because those are not the flags that we care about at all. So can we just kind of whoop? Surely, right? Surely. Surely. Okay, that compiles. I think you can't upload it while we're running, which is crazy. What is it? It's like wayland display. Here we go. Fingers crossed, fingers crossed, fingers crossed, fingers crossed. Fuck. Non-zero modifier. Wait, we got farther. We got farther. Non-zero modifier for unused plane 1. Wait, this is what we wanted. Wait. Let's go back. Let's go back. Modifiers. Splat 0. Modifiers 0 equals modifiers. Fuck yes, dude. Fuck. I'm so fucking stoked. Run that shit. Run that shit. Okay, still another one. But maybe could not create frame buffer. We're fucking farther. We're fucking farther. Where's that log come from? Is that even the same call? Add FB, yes. So, could not create frame buffer. If is error on FB create. Okay, so this is probably just getting into some like deeper thing. So, I think we saw some... We know that it's box DRM, right? So we can look for that. FB create. Which I assume is this mode config funcs FB create, right? So mode config funcs here, so it's probably in here, right? And he's mad because the pixel format is not one of XRGB8888 or BGRX8888. So I know that that's not true. I already know that's not true because from our client, I know that we set that to something else. I remember doing it with my brain. Oh, Windows Zig maybe? And this is going to be in like maybe GBM something. System Zig? So he wants, what was it? What are his two options? X RGB and B RGX. So let's just throw an X on here, right? Fuck it. Fuck it. You can't fucking stop me. Okay. We need to copy, are we DRM gem schmemming? Hell yeah, dude. I guess we're not schmemming. I guess we kind of are schmemming. If you consider schmemming being between processes. We are schmemming the gem schmems. We are schmemming the DRM gems between processes. SCP. Oh, the P key fell off again. I should really just fucking take out that other keyboard I bought. Swayland client root at localhost. Alright. Let's fucking run that shit, dude. Alright. Fingers crossed, fingers crossed, fingers crossed, fingers crossed. Fuck! Could not create frame buffer. But we're getting better. Unsupported, wait, we actually missed all this before. Unsupported pixel format, XR24, little endian. Modifier, a bunch of Fs. Okay, wait. XR24. So who's saying that? There's a 24 kicking around that there shouldn't be, I would think. Unsupported pixel format. Is this the right one? Modifier this. Yeah, it looks like this, right? So if any plane has format gem fb init. So he's mad. DRM any plane has format. So if not any plane uses format, so he's printing the pixel format that we passed in, and he's asking if any plane has that format. DRM any plane has format. So he goes for each plane. If plane has format, okay. So where are our planes getting initialized? Right, because I feel like we haven't like done any plane in it anywhere. What's your keyboard turnover rate? Like probably like 5 years or something. I don't know. I bought one a long time ago because this one's fucked, and I just like never updated it. It's like every time I'm like, I should take out that keyboard because this one's broken. I've never attempted to fix the problem. Let's be clear about that. Like, I just live in shit. It's the life I live. So the question that we need to answer is who the fuck sets up planes? Right? Because like we're not doing that. Right? We're just like, yo, dog, I want to set up a frame buffer. So is there like, I feel like there's like set plane. This guy does get to set flags for the plane. There's also like get plane resources for this thing. So maybe we can like, we have plane pointers, which have formats associated with them. Okay. So the only thing that I can think of here is that set plane does something. Wow, that's crazy. Set plane does something. But like, you know what I mean? It's like, there must be like a default plane associated with the controller. And we're probably like allowed to do things with it, right? Just presumably. DRM mode set plane. Set plane. Let's look at like DRM ioctl. Plane. Plane. DRM mode set plane, right? DRM mode set plane. One word. Right? So like someone in here, he comes in and what does he do with this shit? He like looks for the plane ID, calls like set plane internal. No flags here, which is interesting. Right? Struct DRM mode set plane. Who defines this? Flags comes in here. See above flags. So these are DRM mode flags. So this doesn't seem like it's like setting the fucking like plane format or anything, right? Like it doesn't really seem that way. Maybe we should like iterate. Maybe we should iterate the planes and print their supported formats or something. That's probably what we should be doing, right? Because I think that we saw that there's like a function to do that, right? There's DRM mode get plane resources, or we can even like get plane for this guy who's going to give me a number of formats. So let's just look at plane 0 and just like take a little peek skis. Maybe he'll give us some information, right? Oh, also this guy's using a plane index. So maybe let's at the very least, when we set plane, this isn't attached to a frame buffer. This is attached to a, oh no, here, frame buffer here, right? So maybe it is. Except we don't have the frame buffer yet, right? We're failing in add frame buffer, and he's saying no plane supports this color format before we even could get to the point where we're like before we have a frame buffer ID. So it can't be that, right? Okay. I would love to look at the planes that we support. Let's just do that. Which is DRM mode get plane. And let's just fucking hard code in plain 0 with self DRI file handle. And can we just be like const plain is this? And can we like look at like plain where is it? Plain. Let's just look over the formats. For plain formats. 0 to plain count formats. Or else unreachable. To unwrap the fucking pointer. Let's look at plain formats at I. And can we just like std debug print? I think this is a 4cc code, which if I remember correctly is just 4 U8s back to back. So can we do like you know, as chars is 4 U8s, and can we do like std mem bytes 2 bytes as bytes plain formats I, and then this is gonna be like as chars like this. We can go like 4 we can just like std debug print. I think this is how this works. It's been a minute since we've looked, but I'm pretty sure. And by pretty sure I mean like maybe like 30%. But that's pretty good. Okay. Wait, why doesn't he support field access? Do I have to do this? Hello? Double dereference? No? What the fuck is it pissed about? What does it mean it doesn't support pointer access? Doesn't support field access? Oh, maybe I'm supposed to do 0 here instead. Because it doesn't know. It thinks it's like an array. Ah, and then here it's the same here. There we go. Wrong guy. He's still running. Upload that shit. Run him again. Run this shit. Run that shit. Bang, bang, boom. Wait a second. We segfaulted. That's pretty cool. Oh, no, this is not pretty cool because the segfault's at 58. It's just here. It's just plain was null. That's confusing. That's confusing. Why are there no planes? Okay, we need to look at the picture again. drm02c should have some planes. So the fact that he has none, I guess this means that plane is null. So drm mode get plane is failing, or yeah, because count formats would be valid, right? So he's segfaulting dereferencing null pointer, right? And it's like, okay, why? I guess we should do this. If plane is equal to null, we should be doing this, right? Get planes. And even then, like, we might actually have some information here already about, like, why it failed, right? Nope. All right. Cross. I guess it's like SCP. Swim, and this. Boom, 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 boom. Okay, so we failed get planes, but like why? It's just like giving us like 0 information, right? Unless it's this. Is this new? 5661. 5661. Don't forget. Yeah, not new. So we're just getting E and val on get planes, so we just have to look at the code again. get plane 0, right? We're assuming that's what we're calling. Okay. Wait, do we know what the error code was? That was the new piece of info, right? Error code 2. Linux error codes? Let's fucking get that. E no ent. Interesting. So he's like, plane 0 doesn't fucking exist or something? So maybe the plane IDs are not just like fucking sequential indexes. That's like a very real possibility, right? E no ent, DRM plane find, plane ID, right? It's probably here, right? DRM plane find, tease goes into this guy who does object find. Boom, 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 boom. Which calls this guy, and he's looking for type of plane. Okay, can we go the other, okay, we can just go level up, right? We can just go level up. We can go get planes. Plane resources. Maybe we have to configure a plane. Okay, can we look up like maybe KMS cube surely is, even though KMS cube doesn't do like the import like we're doing, they must render somewhere. They must, right? So do they do any like plane initialization anywhere? So here they already have like a frame buffer. DRM FB. So how do they make these bad boys? They like construct this stuff from OpenGL land. They call add FB2 with modifiers, right? With what they seem to be doing is similar to what we're doing. Right? They throw this stuff in here. They are throwing multiple planes at it, but it shouldn't really matter. And they just call add FB2. So I'm more interested in like when they do this like find CRTC for encoder, find CRTC for connector. Do they do any like initialization for initial init, init for like plane setup? Like it doesn't really look like it, right? They're like doing what we did, right? They're getting resources. They're looking for a connector. They find the connector. They find the preferred connector, and they pick a mode. Do they set the mode? Maybe we need to do that somewhere. They get the encoder for that thing, right? And then they do this. Okay, and then like when they after init DRM, maybe they do some sort of like initialization. It could be like GBM could do some setup that we're missing internally. But then on like DRM legacy, he's just, when he runs, does he do anything up front? No, he just fucking starts running GBM shit. Okay. So on the bright side-ish, nothing in there looks like obviously cooked, but then why can't we get it? You know? Can we look up maybe DRM plane? This is actually the type of shit that the idiot's kind of good at, right? If we're looking at I am trying to write a wayland compositor, initializing my DRM buffers through, you know, whatever the fuck this thing's called, this. As far as I can tell, there are no plane configuration options that can be run before before we have initialized a frame buffer. I guess I should give them a little more context. We can say that we retrieved a gem handle from a enter process DMA buff FD via this guy. Whatever. As far as I can tell, there are no plane configurations that can be run before I've initialized frame buffer. DRM debug logs are complaining that no plane matches the color format that we have passed with our frame buffer. What is it? XRGB 8888. What is the log that the kernel said? Unsupported pixel format. We'll give them the full log. Fuck it. Fuck it, you know? We'll give them the full log. Oopsies. Something about plane 1. This was a different run, right? If you look at the timestamps here, these are like really far apart. So we were kind of like working our way through. This is the latest bug, is this one down here. Define prefixes was not the same. You mean this? Which define? Gem versus gem or something? Maybe, yeah. If you explain more, maybe I'm not quite sure what you mean. Why? What is he complaining about? Am I supposed to be running some form of plane init? I have just run DRM mode, get resources, and walked a few structures to get my encoder, connector, plane, or CRTC mode set up, but have not run set CRTC yet. Let's see if he says something. XRGB 888 ones. I missed a few of those. Oh yeah, I guess so. Yeah, you're saying like one of them says XR24, and the other one's saying XRGB 8888, and one of them is coming from GBM, not necessarily through not necessarily like the same as the DRM 4CC code or something, right? I see what you're saying. I think. Let's see. Let's see if he says anything reasonable. Blah, blah, blah. Why this happens. You create a frame buffer with this converted to a gem handle, then called this with blah, blah, blah. Or you emit the DRM helper checks the available planes, blah, blah. This can happen if the source DMA buff uses a layout modifier. The driver exposes as only with explicit tile compression, but you pass mod invalid. The driver platform, okay, that's like not crazy, right? We do see a fucking like XFFFFFFFF in here, right? Which does seem kind of crazy, right? I would love to double check, like if he might be not like completely out to fucking lunch here, right? DRM format mod invalid, like what is this defined as? Whoa. Wait a second. It's not like a DRM format mod invalid, is it? I guess it is. Unit 64 modifiers? Okay. Modifier can be used to set to terminate the format modifiers list or to initialize a variable with an invalid modifier. It might also be used to report an error back to user space for certain APIs. Okay, that's interesting. We should double check what our modifiers are supposed to be from user space land. Because that is a little bit interesting. A little bit. Undefined. All right, there we go. Cross and copy. Swim. Wayland. Again, we never trust this guy, but he might have some good ideas, right? Modifiers, that does look fucking invalid. Okay, so what does he say about this? You not to, okay, so this lines up with my understanding. that I don't have, that he's agreeing that I shouldn't have to set up any planes. Plane setup happens later at atomic commit. Yep, agreed. Yeah, okay. So I'm curious to know. The kernel message decodes XR24 little Indian. That is DRM format XRGB8888. Cool. It could be, you know what? In that box thing, it did give us the other option, right? Just on a whim, it could be that, like, he's not checking correctly. So we might want to try the other option, right? He said, like, XRGB. No, it was in the kernel docs. XRGB8888 in, like, DRM box or something. Right? He had BGRX8888 as well. These are the two options. So maybe, like, just we could try on a whim switching to the other one. Right? Just maybe. Client. Because, if that happened to work, that'd be kind of hype. So wait, what was the other option? It was BGXR? BGRX. Whoa, XRGB and BGRX. Okay. Oh my god, Kiki fell off again. BGRX, right? Which is just RGBX backwards. Okay. Something that and then we should also start looking at all of our potential planes as well. That was another thing he was suggesting that we were already on our way to doing as well, so I might as well. Where was this? Get plane. So instead of get plane, we want to do get plane resources or something. Where was it? Get plane resources for this file descriptor. Plane res. Okay. And then we can look at this returns this, which is count planes and planes. So here we do this and we say for plane res 0 count planes, we have plane index. And then we have for plane for 0 to plane index. No. Plane res 0 planes plane index. Count formats like this. I guess we should do this. Const plane is oopsies. This, right? And then we should be going for plane count formats. We look at plane formats. Okay. Is this okay? He's mad because plane fine. Res index. Count formats. Whoa. Whoa, 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 whoa. Plane ID? Let's look at this. Plane ID. So this is great. Maybe this is where we were getting confused. So we have the plane here as DRM mode get plane from plane ID. Maybe these weren't sequential. And then we kind of do this. Okay. Let's see how this goes. Okay. Okay. RM this, wayland displays this. Let's just see what happens. Okay. So we're back in the same thing, unsupported pixel format right here. XR24. Oh, fuck. We also wanted to update the wayland client. I forgot. Might as well try that too. No config. So he can't even start to send something when we use the backwards format. OpenGL is not exposing that to him. So that's a good clue. Maybe. I don't know. It's a clue. Cross SCP. Okay. Okay. So, are there just no planes? Right? Like, what the fuck is going on? Where it looks to me like we say, like, get plane resources, and we're like, found this many planes. Like, we're not printing anything, right? Like, what the fuck is going on? You know what I mean? Like, I feel like we should be seeing something. Got 0 planes. Like, that seems like the fucking bug, right? Like, of course we can't render anything if this thing just has no planes. Is it like DRM box is fucking wrong? Are we running the VM wrong? That seems kind of likely, right? Is that because there's no GPU? But it has like a DRI handle. But yeah, it could be, right? Like, can we change this? Like, QEMU vert IO GPU. Because like we are also seeing like this like driver shit, right? So like maybe there's like a bug there. Device vert IO GPU. Does it run locally? It's like kind of too hard to tell. Because I have to like go into a virtual terminal and stuff. Okay, let's try this. Well, this is concerning. Now the VM just isn't even booting. Oh wait, here we go. Okay. So the question is, first of all, test. Not good. Vert IOGB. Oh, that's what it is. Okay. So we're up, little face, height. So remember, we did have a way to make the, like, talk to the face. So also, there are 2 cards in here, which is interesting, right? That's definitely something to think about. But okay, let's run swim. And okay. Wayland display. Okay, so this guy's not complaining about GPU drivers anymore, which is kind of good. But we still are not in not getting what we want. Can we go back to parameters here? Do we remember what the bit was? Echo for debug. Let's just kind of rip this shit again. Let's just, because I think that we're on a different driver path now, which is like maybe interesting info. Driver does not support FB modifiers on vert IO PCI. How interesting. So maybe, hold on. Maybe that was the case as well with box, right? Maybe maybe we're supposed to check if modifiers are supported and not pass and call a different function, right? I think I've actually seen that in KMS Cube. I think. Add FB. Yeah. Yeah? I mean, they do have this option, right? So we could try that. So we could do what they do, where they try this, and if that fails, uh, then we can call DRM mode add FB2 and just say like fuck modifiers, bitch. Fuck modifiers. So handles, strides, and offsets are all the same, just no modifiers, right? Width, int cast height, format, handles, strides, offsets, FB, ID. Do this, right? Something like this. If this is not equal to 0, we kind of do, then we like freak the fuck out. All right, something like this. We can try it. All right. Oh. Let's fucking go! Let's fucking go, baby! That's fucking sick! All right. So these guys just don't support modifiers. So I'm curious to go back actually and go back to the box driver as well and see if that like we get the same shit. Bro is surprised too. Well, I mean, at this point, it's like we tried a bunch of things. You know, some of them work, some of them don't. Hello, hello, you caught us at just the right time. Oh, the monkey head. Yeah, he's also surprised. Ooh. All right. So we start the window manager. We run Wayland client. He's getting pissed about missing drivers and stuff, but we can... Oh no, because we still have like the found 0 planes problem here, right? So there's still something wrong here where, yeah, there's something interesting about the box driver not having any planes, right? So here we did manage to like initialize this thing correctly, but it's like obviously showing nothing because in this picture, wherever the fuck, this one, it's like this controller is just getting data from nowhere, right? So there's something there, but at the very least, if we enable virgl, we're fucking back to being chilling. So let's just do that so we can feel good about ourselves. Oh, sorry, it's actually vert io GPU, right? Was what it was. I think it was something like that. I just want to run it one more time so we can be like, mwah. Obviously there's like more work to do here, right? Because we're only ever showing one frame coming from the client. But that's a lot better than 0 frames. Like a lot better. Like we're like a lot better. So that's pretty exciting. That is pretty exciting. So the path here is our client opens up an OpenGL context using GBM to back his buffers. He renders this monkey who's loaded from inside his executable. He takes that buffer, turns it into a prime file descriptor, hucks it over the fucking network to our other Wayland compositor process. That guy eventually gets that. He does a bunch of chatter, does all the setup to like get what he wants. He gets the buffer back and he fucking hucks that shit on the screen. Which is super cool. Super cool. Yeah, I'm pretty stoked. Next up, I guess, is, you know, supporting animation and multiple displays and like maybe like positioning them separately. We're gonna have to figure out this this plane bug for sure. I think they're like, clearly you can do something when there are 0 planes because our like test executable drew something. But yeah, we'll have to see where that goes. I would like to do some investigation there because we're clearly doing something wrong. Another odd thing we should do is we should be looking into if KMS cube works with the box driver or whatever, but Anyways, lots to look into. But I think we call it there. So it's 4:30. We've got a 2-hour stream. Nice, satisfying endpoint. Thanks for watching, guys. If you like what you saw, we stream most days. We aim for 12:30 Pacific time to 4 o'clock Pacific time. It's 4:30 now. We ran a little long today, but that's okay. Happens sometimes. We're working on this window manager as kind of like part of a larger project to work on a phone operating system eventually. We're kind of doing like the Linux side now. We might spend like a bunch of time rabbit holing on this before flipping back, but the long-term goal is it would be cool for us to write like a operating system on for our phone that we could like have our own window manager and our own calculator app and our own browser and all that shit. But yeah, if you want to support, there's Patreon, YouTube members, and Twitch. On all 3 of those platforms, if you subscribe, you get access to the other half of streams. So like today we were working on some low-level container stuff that was kind of like a background thing that I've wanted to do for a while to fix like usage of our segmented list in our like custom allocator scheme. So we did that from 12:30 to 2. If you want to check that out, next time you either have to catch us live or subscribe wherever it makes sense. If you subscribe, you get access to that stuff as well as the information that you are helping the stream continue. Because when I run out of money, I will have to get a job. Anyways, that's the old plugin. YouTube, peace out, and Twitch, let's find someone to raid.